Let's solve 2 times 3 to the x equals 5 times e to the x. Note that we're asked to obtain an exact solution. One way I can think about solving this equation is to take logarithms of both sides. Let's take the natural log of both sides of this equation. Then we have natural log of 2 times 3 to the x equals natural log of 5e to the x. Now I can use the product property of logarithms on both sides of the equation. This gives me natural log of 2 plus natural log of 3 to the x equals natural log of 5 plus natural log of e to the x. At this point I can use the power property of logarithms on natural log of 3 to the x and on natural log of e to the x. So I have natural log of 2 plus x times natural log of 3 equals natural log of 5 plus x times natural log of e. Now let's move both of the terms involving x to the left-hand side of the equation, and both of the terms that don't involve x to the right-hand side. So I'm going to subtract x natural log of e from both sides of the equation, and I'm going to subtract natural log of 2 from both sides of the equation. This gives me x times natural log of 3 minus x times the natural log of e equals natural log of 5 minus natural log of 2. Now on the left-hand side of the equation, I can factor an x out. That gives me x times the quantity natural log of 3 minus natural log of e equals natural log of 5 minus the natural log of 2. Now let's divide both sides of the equation by the quantity in parentheses. This gives me x equals natural log of 5 minus natural log of 2 all over the quantity natural log of 3 minus natural log of e. Now let's simplify that natural log of e. The question you need to ask yourself at this point is, since natural log means a base e logarithm, e raised to what power gives me e? Well, that would be 1, of course. So we have x equals natural log of 5 minus natural log of 2, all divided by the quantity natural log of 3 minus 1. Now there's another way we could think about solving this equation. Some people prefer this other method, where we look at our equation and move some of the factors around first. So what I'm going to do is take both of the factors that involve x and make sure that they're on one side of the equation together, and both of the factors not involving x and put them on the other side. So I'm going to move e to the x, and I'm going to move 2. So I'll divide both sides of the equation by e to the x, and I'll divide both sides of the equation by 2. This gives me 3 to the x over e to the x equals 5 halves. Now I can write 3 to the x over e to the x as 3 over e all raised to the power x. And this still equals 5 halves. At this point I'm going to take the natural log of both sides of the equation. So I have natural log of 3 over e all raised to the power x equals natural log of 5 halves. Now I can use the power property of logarithms on the left-hand side. Given me x times the natural log of 3 over e equals the natural log of 5 halves. Now to isolate x, I'm going to divide both sides of the equation by natural log of 3 over e. So I have x equals natural log of 5 halves over natural log of 3 over e. This doesn't look quite like the solution I got when I solved this equation the other way. I'm going to use the quotient property of logarithms to rewrite the logarithm in the numerator and the logarithm in the denominator. So I have x equals natural log of 5 minus natural log of 2 all over the quantity natural log of 3 minus natural log of e. This was our second to last step when we solved this the other way. The only thing left to do here is simplify natural log of e. Again, we're asking ourselves, e raised to what power gives me natural log of e? Well, that would be 1, of course. So we have x equals natural log of 5 minus natural log of 2 all over the quantity natural log of 3 minus 1. Now I have the answer in the same form as when I solved it the other way. And this is an exact solution, meaning we didn't get a decimal approximation. Most times in applications we will want a decimal approximation, but pay attention to what the question asks you for. In this case, our problem stated that we were supposed to obtain an exact solution. So this is how I want to leave my solution.